are now listening to the Evolution 101 podcast.
Hello everyone, and thanks for listening. My name is Zachary Moore, and you can email me directly at zach@drzach.net. You can also send feedback or submit questions for the podcast through the website at drzach.net, which also links to the archive page at freethoughtmedia.com and the ever-present Molecular Evidence for Evolution, Examples of Molecular Homology. Just click on that green chalkboard up in the corner to see a few examples of how genes from different organisms can be lined up to show the gradual genetic change over evolutionary time. I'd like to thank those of you who have donated to Evolution 101. I've received several donations over the past couple weeks, and while they are not necessary, they are appreciated. If you're so inclined, you can find buttons both at my website and at the Free Thought Media website to do so. All right, well, now on to listener questions. I do appreciate all your questions, but this podcast is getting just a little bit too popular for me to answer them all. Keep sending them in, though, and I'll do my best to answer as many as I can, both in direct replies and also here. The first question is from Danny, who asks, a friend was offering some counters to evolution, though he admits there aren't any other scientific theories to replace evolution. One specific case he mentioned was the development of the human eye, or even eyes in general. He seemed to be making an argument of irreducible complexity for vision, which I talked about a little bit. However, it did make me curious. How did vision evolve? Well, first of all, Danny, if you remember from the podcast on irreducible complexity, this kind of argument is an argument from personal incredulity. That is to say, since your friend cannot conceive of a method by which the eye could have evolved, such a development was impossible. This is, of course, logically fallacious. Just because your friend isn't aware of such a method or doesn't possess sufficient imagination, it does not follow that evolution of the eye was impossible. This problem was actually singled out by Charles Darwin himself, who is often quoted by evolution deniers as saying that the evolution of the eye is, quote, absurd to the highest degree. This is another example of a dirty rhetorical trick, quoting out of context. Darwin did say this, but out of sheer scientific integrity and, as I've mentioned before, acting as his own worst critic. Darwin concedes that for such a complex organ to evolve seems counterintuitive, but much in science is counterintuitive. What most evolution deniers don't mention is that after saying this, Darwin goes on to lay out a perfectly reasonable method for the evolution of the eye as predicted by his theory. First, there would be photosensitive cells, followed by clusters of pigmented cells, and then an innervated cell cluster covered by a translucent membrane, then the formation of a small depression followed by a deeper depression, then lens-like skin covering that depression, and finally the development of muscles allowing this lens to move. There are organisms in existence today which are known to have each one of these structures as a viable method to detect light. In addition, certain genes which are found in organisms that are known to be essential for the formation of a lens are also found in organisms which do not have lenses, suggesting that these non-lens genes have been co-opted from structures lacking a lens. Unfortunately, eyes are structures that do not readily fossilize, so we cannot compare the evidence to the fossil record, but this is certainly a plausible evolutionary explanation. Jeffrey asks, if we never treat a virus like HIV, would the body eventually become immune to it through generations? Or are some things too lethal to become immune to? In other words, would it be quicker to let the human body build up its own resistance to it by letting HIV-infected people reproduce over and over with other HIV-infected people until they had an offspring that was immune to HIV, and then synthesize the chemical resistance made from that offspring for the masses, instead of introducing drugs into the human body that try to resist HIV but can never hold it off fully or cure it, making HIV and AIDS adapt and become that much stronger? This is a tricky question. in that it has obvious ethical repercussions. But let me address the most obvious mistake first. Failure to treat an individual for HIV would not make the body immune to it over generations. This is what is known as Lamarckian evolution, the inheritance of acquired characteristics. This is not evolutionary theory as we understand it today. Darwinian evolution posits the mechanism of natural selection as the adaptive mechanism. How this would work is, let's say you had a population of humans and infected them all with HIV. Well, only the ones which were already more resistant to it would survive, and the rest would all die. After many successive generations of this process, eventually those individuals which had the highest genetic resistance to HIV would contribute the most DNA to the population's genome, and eventually the bulk of the human population would be, more or less, immune to HIV. This would not necessarily be a chemical resistance, but more likely a genetic resistance, as we can see with those individuals who are already resistant to HIV, by virtue of the fact that they lack expression of the chemokine receptor 5, which is a co-receptor for the HIV virus. Current drug development efforts are being made to exploit this fact, but the natural resistance is in fact genetic, not chemical. There are often criticisms of the currently available HIV treatment drugs, since they often have unpleasant side effects and can potentially be unsuccessful. But I would point out that even the genetic resistance that I mentioned just before is not perfect. The co-receptor deficiency may work for one strain of the virus, but it's possible that the virus could mutate and use a different co-receptor to enter host cells, in which case the initial mutation is worthless. Evolution is almost like a competition between organisms, each competing to replicate its genes more than the other, and when the relationship between those organisms is as parasitical as a virus to a host, well, that competition is deadly serious. The virus cannot exist without a host, and the host cannot exist with the virus. There will always be mutation and adaptation on both sides. That's just the way evolution works. And finally, Sean asks, why do people have pubic hair and underarm hair? Well, I think the more interesting question is not why do people have hair in these weird places, but why don't they have hair anywhere else? Or, in other words, why are we naked? Well, the standard answer to Sean's question is that pubic hair and underarm hair are visual sexual cues. Hair begins to grow in these locations during puberty, hence pubic hair, signaling to others in the population that individuals with pubic hair are sexually mature and ready to procreate. Now, modern humans have adopted the use of clothing, and so the impact of this particular visual cue is less relevant today. But that's an interesting development on its own. The only reason we wear clothes is because we're naked. So, why are we naked? All other primates are well covered with a thick complement of hair. In actuality, we have just as much hair as the others in terms of hair follicles. Well, look closely at your skin and you'll see them, thin and tiny, but definitely there. But our hair tends to be a lot more thin and tiny than the hair on, let's say, a chimpanzee. So much so that on a rough inspection, the zoologist Desmond Morris has no qualms in classifying humans as the naked ape. The mammalian clade is distinguished by its hair, and by far, most mammals have hair aplenty. Hair can be extremely useful. It warms and insulates those mammals which have to deal with cold temperatures, and it shields from the sun those mammals which live closer to the equator. Only a few groups of mammals have given up their hair. Burrowing mammals like the aardvark or the naked mole rat, and aquatic animals like the cetaceans or the hippopotamus. In both of these cases, it's clear that hair would be more trouble than it's worth, trapping dirt in the former case and slowing down swimming speed in the latter. Even competitive swimmers know to shave off their hair before getting in the pool. But how did this happen? Well, unfortunately, hair and skin does not readily fossilize, and so there is very little in the fossil record that exists to help us answer this question. But there are some very likely hypotheses that take into account what is known about our evolutionary origins. The best one, in my opinion, is that which suggests that neoteny is the reason for our nudity. Neoteny is the retention of juvenile characteristics into adulthood. One classic example of this is seen in the salamander axolotl, which, unlike other salamanders, does not metamorphose into a terrestrial form and stays aquatic, retaining the external gills that would be lost during this process. Interestingly, the axolotl can be induced into metamorphosis if given the proper hormones, or if their environment is properly manipulated. If this happens, they lose their gills and turn from pink into a dark mottled terrestrial form similar to a tiger salamander, to which they are likely related. As it happens, there are several aspects of juvenile chimpanzees which are also found in humans, supporting the idea that humans are a neotenic species of great ape. At birth, a chimpanzee is almost completely hairless except for, well, on top of the head. This would, of course, explain our nudity, but it also explains a number of other human aspects, especially our ability to learn. Young chimpanzees have an incredible capacity to learn that is turned off upon entering maturity. But in humans, this capacity continues throughout adulthood. Proportionally, the chimpanzee head is much larger in relation to the rest of its body as a juvenile, similar to the proportions of the human head to the human body. It's in fact quite possible that neoteny may have been selected for the intellectual benefits, and nudity simply followed as part of that process. But it is reasonable to think that if our nudity is a result of being neotenic apes, there could have been some compelling selective reason for this change. There are many explanations for this to have been the case. One is that, as you remember from the previous podcast on human origins, our ancestors distinguished themselves from their fellow apes by the ability to hunt. Upon abandoning a nomadic existence, their homes would have been infested with insects and parasites, which would have been a problem for those with hair. However, many other hairy organisms deal with skin and hair parasites without much problem, so this seems unlikely to have been of much importance. Another suggestion is that the transition to hunting would have exposed our ancestors to blood and guts and other detritus in the butchering process, which would have been a liability if they'd had a hairy coat to become matted and sticky with the meaty muck. For example, vultures have lost the feathers around their head and neck due to the fact that they're always sticking them in sticky and nasty places. But certainly if our ancestors had the intelligence to develop the tools necessary to bring down prey, they also would have been able to use those tools to skin and process their prey without making a disgusting mess. Others make the suggestion that, upon the discovery and management of fire, the need for warm insulation at night was no longer a selective pressure to maintain a full body of hair. There is another interesting idea called the Aquatic Ape Theory, which suggests that during human evolution, our ancestors left the trees which they were accustomed to and moved to an aquatic environment of some sort, either by the ocean or near some marshland. Other mammals which have returned to an aquatic existence have also lost their hair. Cetaceans, as I mentioned before, and hippos. This theory also explains several other aspects of human physiology that is different from the other apes. For example, humans tend to be fairly agile in the water, even at a very young age, unlike chimpanzees, which are very poor swimmers and easily drown. It may explain why our bodies are more streamlined than other apes, and even why we have vertical posture, presumably from having to hold our bodies upright in deep water. In addition, the hairs on our backs are angled diagonally toward the center of our spine, which is different from other apes did to the flow of water across the back. This also explains a particularly notorious difference between humans and other apes: thick deposits of subcutaneous fat. No other apes have this characteristic, but it is argued that fat deposits are particularly useful for other marine mammals, in that they aid in flotation. However interesting this theory may be, there is unfortunately no good fossil evidence to support it, although there has not been much investigation of human ancestor fossils in areas which would have been aquatic in the past, but it still remains a minority view. Another beneficial aspect of nudity was the impact on body cooling. As hunters, our ancestors had to exert themselves to an extent which their evolutionary heritage had not prepared them as efficiently as it had for other hunters like lions or wolves. In order to pursue their prey, our ancestors would have experienced severe overheating, to the extent to which the lack of body hair would have been a great benefit. This loss of protection during the day could have been offset by the gain of protection from the cold afforded by the subcutaneous layer of fat that I mentioned before. Well, getting back to what I initially answered about the existence of pubic hair, nudity may have been selected for as a sexual signal. Male humans are distinctively hairier than females, and it's entirely possible that the lack of hair on a female would have been an attractive signal for males. Carried out over many generations, this sexual selection would have resulted in an overall lack of body hair in both sexes, with more pronounced nudity continually seen on the female. This would also be consistent with the retention of pubic hair, as I mentioned before that this hair is a distinctive sexual cue. So we see that the reason for human nudity is most likely because of neoteny, which is the retention of juvenile traits throughout adulthood. Like young chimpanzees, we lack thick hair all over our bodies, except for our heads. This may also have been tied in with our brain development. The selective reasons for this change could be from a number of explanations, including parasite infestation, the domestication of fire, an aquatic existence, the demands of a hunting lifestyle, and sexual cues. Alright, well that's all for this week. Take care.